The goal of today's lesson is to determine if a coordinate, like x comma y, is a solution, an answer, to a linear function. We know linear functions are like equations or rules, such as y equals 2x plus 2 is a rule. So we're trying to determine if ordered pairs, if coordinates are answers to a linear rule. And the important parts to remember is that a linear function has infinite amount of answers, infinite amount of solutions. However, this does not mean that any ordered pair will be a solution. So not every coordinate is a solution, only certain ones are answers. The only points that are solutions to a linear function are those that are on the line. So if we graphed it, the solutions, the answers are on the line. And this means that they make the equation of the function true. We're going to see what this looks like later. Reminder, solutions to linear functions can be represented in three ways: as ordered pairs, x comma y, as a table of values. So what that might look like is an input-output table, like 0, 1, 2, and then on the output, 10, 7, 4. These would be all answers to a linear function. And they can also look like a graph. So we've graphed these before, and we've made linear lines. And this is a reminder that any point that is on the line, well, these are solutions. They're going to make the equation true. So this is some important stuff to remember as we work through the next 4 examples. Question 1 says determine which point, A, B, or C, is a solution to the equation below. So I see my equation says 2 times the input minus 3 times the output equals 12. Or 2x minus 3y equals 12. And I want to figure out which ones are solutions. So what I'm going to have to remember is coordinates are solutions if they make the equation of the function true. So if this coordinate makes the equation true, then it is a solution. So we're going to do this by a guess and check method. So for example 1, I'm going to try to see if A works. Here is my function rule, 2x minus 3y equals 12. And we're going to see, does negative 3, 2 work? And the first thing I want to remember is a coordinate is made up of an x value and a y value. So I'm going to use substitution here, and in place of x, I'm going to place negative 3 in. And in place of y, I'm going to put in the value of 2. And I'm going to see, does it work? So everything stays the same except for my x, my input, and my y, my output. 2 times the input, 2 times negative 3, minus 3, or plus negative 3, times the value of y. We said the value of y is 2, equals 12. So this is the big step here, is knowing that a coordinate pair is made up of an x and y, and then I replace the x and y in my equation with my choice. 2 times negative 3, using a calculator I can get negative 6, plus negative 3 times positive 2, which is also negative 6, equals 12. And I ask myself, does negative 6 plus negative 6 equal positive 12? And of course the answer is no, because negative 12 does not equal positive 12. Negative 6 plus negative 6 is negative 12. And we know negative 12 does not equal positive 12. So A is not a solution. So I have to try B. Does B work? Well, B is the coordinate 0, negative 4. So again, I'm going to take my equation, I'm going to write it down. 2x minus 3y equals 12. I'm going to replace x with 0, replace y with negative 4, and see if it works. 2 times x, which is 0, minus or plus negative 3 times y, which is negative 4, equals 12. And now I simplify. 2 times 0 is 0. Negative 3 times negative 4 is a positive 12. Does 0 plus 12 equal 12? Yeah, it does, right? Because 12, 0 plus 12 is 12. 12 does equal 12. It works. So what does that mean about B? 0, negative 4? 0, negative 4 is a solution, or is the solution to this equation. I'm all set. In example 2, which are the coordinates of a point on the line? Well, in class we actually changed this equation. We changed it to y equals negative 1/4 x minus 1/4. Okay, so make that change on your paper. And again, same idea here. Which of these 4 points are a solution which are on the line of this equation? So one way I can do this is by, again, plugging in x and y for each of these choices. Or I can also do this by graphing. So if you have a set of graph paper, follow the steps we did here. Here's my rule. My equation was y equals negative 1/4 x minus 1/4. I created an input-output table. I chose a negative, 0, and positive, and I plugged each of these inputs into my rule for x. I then used a calculator to help me compute this. Negative 1/4 times negative 4 minus 1/4 is 0.75. Negative 1/4 times 0 minus 1/4 is negative 0.25. And my input of 4 that I chose, negative 1/4 times positive 4 minus 1/4 is negative 1.25. And then I plotted these 3 points. Negative 4, comma 0.75 is right here. 0, comma negative 0.25 is this coordinate right here. And 4, negative 1.25 is this coordinate right here. And then I made the line that connects these 3 points, the linear function. Now if I go back and look at my original question, what are the coordinates of a point on the line with this equation? Well, let's see. Does negative 10, 3, is that on the line? Negative 10, 3 is that coordinate there. That's not on the line, so it's not a solution. negative 7 comma 2 is not on the line. It's close, but it's not quite there. So it is not a solution. 6 negative 1 is exactly on the line, which means negative 6 comma 1, 6 negative 1 is a solution to this equation. Again, strategy 2, you can always make a input-output table, graph the line, and see, do these points fall along the line? And the only one that works, we can even show 7 negative 2 is just off the line. The only point that works is choice 3. Moving to example 3. Example 3 asks us, give 2 solutions and 2 non-solutions to the line below. So reminder, solution means on the line. Non-solution gonna mean not on the line. So we can find a lot of different examples, but the question only asks us to find 2 solutions and 2 non-solutions. So if I look here, I see, 1, 2, 3, 4, 5 coordinates jumping out at me. These are all solutions. So I might pick negative 3 comma negative 4. That is a solution. I could also choose the point 0, 2. That's on the line. So that's a solution. Non-solutions, well, that just means any point on the coordinate grid that's not hitting the line. So I don't know. This point works. 4 comma 2 is not a solution. It is not on the line. And let's try a couple negatives. Let's try negative 3, negative 2. That also is not a solution. It is not on the line. So there is a couple different answers for example 3. There's many more that you can come up with. And then the last example before you can do the classwork is example 4, which says, Mr. Lee graphed the function y equals 3x plus 4. Okay, so he graphed this line. We can't see it yet, but we want to know which of the points J, M, K, or L on the graph are below this line, and here are our answer choices. Well, we know how to graph a rule, so that might be the best thing to do here, is make an input-output table, inputs x, output y, and here's our rule. Our rule says multiply the input times 3 and then add 4. What's our inputs? Well, I can see negative 1, 0, 1, 4 are all good choices. Negative 1 we'll start with. When I input negative 1, 3 times negative 1 plus 4. Using a calculator, 3 times negative 1 plus 4 is positive 1. If I go to graph this, negative 1, 1 is on the line. Oh, it's J. So J is a solution. J works. How about 0? Let's try 0. Y equals 3 times 0 plus 4. Calculate 3 times 0 is 0, plus 4 is 4, 0, 4. Where is that point? 0, 4 is M. M also works. And let's just actually graph one more. Let's try 1. When x is 1, that means it's 3 times 1 plus 4. 1 is our input. Let's calculate our output. 3 times 1 is 3, plus 4 is 7. 1 comma 7 is actually not even on the graph. It's somewhere way up there, which we know we're not supposed to graph. So I can find at least 2 points. I know J and M are on the line, so I can actually even make the line that connects J and M. And if we could see it, 1, 7 would also be on the line. But that's the line y equals 3x plus 4. So which points on the graph are on this line? J, M, K, and L are not. So where is the choice J and M? So there was a lot of different strategies to answer this question. You can make an input-output table. You can find coordinates on the graph. Or the new strategy we saw in example 1 is to replace x and y with the coordinates you're given, remembering that the first value is x, the second value is y. Whichever equation results in a true statement is the correct solution. Thanks for watching.